10 years ago, a team running the world's largest particle collider made history by discovering the Higgs boson particle, a discovery essential to understanding the origin of the universe that earned it the moniker God Particle. Hello everyone, and welcome to another video. Today we'll be looking at CERN scientists announce something weird is going on after they turned on the Large Hadron Collider. Yeah, you heard it right. After a more than 3-year hiatus for improvements, the European Organization for Nuclear Research, or CERN, operated accelerator is once again collecting data. This time the mission is to prove the existence of dark matter, another mysterious substance. Although most scientists accept that dark matter exists, none have been able to observe or produce it. Large Hadron Collider data collecting and power enhancements could present scientists with one of the best opportunities to image and comprehend the substance. The professor of physics at New York University, Joshua Ruderman, stated, "If we can determine the features of dark matter, we will learn what our galaxy is composed of. It would be revolutionary." For decades, dark matter has interested physicists. It is widely considered to constitute a considerable portion of the universe, and learning more about it could shed light on the origins of the universe. According to CERN scientists, the stars, planets, and galaxies in the cosmos account for only 5% of the universe's stuff. Around 27% of the cosmos is believed to be made of dark matter, which does not absorb, reflect, or emit light, and is therefore extremely difficult to detect. Researchers assert its existence because they have observed its gravitational effect on objects and its ability to bend light. Researchers have high hopes for the Large Hadron Collider. The European Organization for Nuclear Research constructed the collider over a decade to assist in answering lingering puzzles in particle physics. The machine is situated around 100 meters below ground in a tunnel near the French-Swiss border and Geneva. Its circumference is approximately 17 kilometers long. Inside the collider, superconducting magnets are cooled to temperatures colder than space as two particle beams moving close to the speed of light collide, using sophisticated sensors and monitors. Scientists study the compounds produced by these collisions, which simulate conditions similar to the Big Bang. It permits them to learn about the universe's earliest moments. The machine began operating in September 2008, but has been shut down numerous times for upgrades. Engineers have spent the past 3 years enhancing the collider so that it can detect more data and operate at higher speeds. Now that the accelerator can operate at its highest energy level ever, 13.6 trillion electron volts, scientists are able to conduct larger, more complex experiments that may give new insights into particle physics. Mike Lamont, CERN's head of accelerators and technologies, referred to this as a substantial rise, creating the conditions for future discoveries. At the beginning of the universe, particles lacked mass. Thus, scientists have long pondered the origins of stars, planets, and additional forms of life. In 1964, physicists Francois Englert and Peter Higgs and others proposed that a force field gave particles mass when they interacted, but they were unable to prove the entity's existence. Englert and Higgs received the Nobel Prize in Physics for their discovery of the Higgs boson, a component of the theorized force field. The particle has captivated both scientists and the public. CERN and the collider are significantly portrayed in the Angels and Demons novel and film adaptation by Dan Brown. Nonetheless, scientists today seek answers for more perplexing problems, particularly those concerning dark matter. During the 4-year experiment of the Large Hadron Collider, scientists hope to find evidence of dark matter. As soon as the machine is activated, the protons will spin at nearly the speed of light. The hope, according to the researchers, is that when they collide, dark matter-like particles are created. They also want to learn more about how the Higgs boson particle acts. On Tuesday, just after the collider began gathering data, CERN scientists announced the discovery of 3 new exotic particles that may provide light on how subatomic particles bind. Giorgio Giudice, head of CERN's theory department, remarked, "High-energy colliders remain the most powerful microscope at our disposal for exploring nature at these smallest scales and discovering the fundamental rules that govern the world." Ruderman of New York University said CERN's mission to understand dark matter and explain the beginnings of the universe has him eagerly awaiting the results of the experiment. "The research tremendously fascinates him. It's the reason I get up every morning," he remarked. Once data begins to emerge from the experiment, Ruderman will determine whether or not it is manufacturing new particles. Even if it does, it will be difficult to determine quickly if it is dark matter or not. They must first determine whether the particle in question emits light. If it does, then that makes it less probable that it is dark matter. Dark matter should, in theory, be able to persist for billions of years. Therefore, the particle should exhibit signals of long-lasting evidence rather than quick destruction. They also hope the particle acts similarly to current models of dark matter. Rudderman suggested it may take more than 4 years to make the discovery. If CERN scientists do not uncover dark matter in the next 4 years, they have additional enhancements in the works. The enhancements will likely take 3 years after the current cycle concludes, leaving 2029 for the commencement of the 4th round of data collection and experiments. According to CERN's website, the study might collect 10 times more data than previous experiments if all goes as planned, but deciphering the universe's secrets isn't easy. Rudderman stated, "This is difficult and would require a lifetime of investigation." So that's all from today's video. If you enjoyed it, remember to leave a like, subscribe, and ring that bell icon so that you never miss our upcoming videos. And don't forget to share your thoughts in the comments section down below. Stay tuned, and we'll catch you in the next video.